Hey guys, welcome back to my CCNA 203.01. Patrice is here, and in this video we are going to talk about networking models. Are you ready? Let's get started. Computers, just like human beings, need a common language to talk. This common language in computer terminology is called a protocol suite, protocol, or networking model. In the early days of computer networking, this was the vendor's responsibility to develop such a common language. SNA, or Systems Network Architecture, was one of these vendor-specific protocols which was developed by IBM. After a while, having a standard version of a networking model looked necessary. ISO, or International Organization for Standardization, developed a networking model called OSI, which stands for Open Systems Interconnection. Another effort supported by US Department of Defense and United States universities researchers' work led to a protocol called TCP/IP. Initially, companies started to adopt one of these protocols, or both of them. However, in the end, TCP/IP was the winner of the competition, and the internet and also our local networks was built based on TCP/IP. OSI still is a reference model, but the domination belongs to TCP/IP. In the recent version of CCNA 203.01 exam, there is only one topic that directly relates to the networking models, and it is compare TCP to UDP. However, from my point of view, TCP/IP and OSI basics are pillars that you build your networking knowledge on them. Therefore, I cannot ignore this topic, even if Cisco removes it from the exam topics. So, if you got networking knowledge at the CompTIA Network Plus level, you can simply ignore this video as well as the next
To have a
videos
better
which
understanding
talk about
of a
TCP/IP
layered model,
basics.
we need to know
Otherwise,
how data
invest
flows
some time with
through
me
a networking
and these
model.
basic
I
videos
want to use
so you can
OSI
have
for
a
my
solid
example.
foundation for your
When
future
we say
growth.
networking models are common languages, it means both sides need to be able to talk with that language, obviously.
So in this example, computer A and computer B are able to speak with OSI language. If we assume that some data need to be transferred from computer A to computer B, the related application, let's say the web browser, will deliver the data to the application layer. So we got some data here, and this data delivers to application layer to be transferred to the network. Then application layer will add some descriptive data that are necessary for data transfer. These data will be added to the beginning of the initial data. So we call it a header. So this is our initial data. And then application layer adds some information here. So it is called application layer header. And this data delivers to the next layer, which is presentation layer. Presentation layer also takes this data as the initial data and then add its own header to the data and delivers it to the next level or layer. This process continues layer by layer till the data link layer, and each layer adds its related data in the format of a header. The data link layer is the only layer that adds some data to the beginning of the data like other layers, as well as some data at the end of the data. So we got this data from the previous layer, which includes all information from previous layers as well as the initial data. And then data link layer will add a header as well as a trailer to the data. This process is called encapsulation. And finally, physical layer will deliver these data in the format of zeros and ones to the destination. On the other end, the physical layer delivers the zeros and ones to the data link layer. And this is the data link layer responsibility to reproduce the data and removing the header and trailer and delivers it to the network layer. So data link will reproduce the frame. I will talk about the different packet names in the future videos. In the data link layer, we call it a frame. And then removes the trailer and header, which belongs to this layer, and delivers the rest of the data to the network layer. And network layer does the same process, removes the network layer header and delivers the data to the transport layer. And it continues up to application layer. And finally, application layer removes its own data and delivers the data to the computer B. And this process is called decapsulation or de-encapsulation. So finally, if everything was fine in the encapsulation and the encapsulation process, the same data should have been delivered from computer A to computer B. But why OSI is so important, although it is not used in any commercial network? OSI is there for our reference. Whenever anyone wants to talk about a protocols layer, a device layer, or anything that is related to layers, our reference is the OSI. For example, IP or Internet Protocol is a protocol that belongs to TCP/IP. We will talk about it later in next videos. And it works in layer 2 in that model, but everyone says IP is a layer 3 or network layer protocol, which both reference to OSI. I just want to give you a one sentence definition for each layer's duty. However, you can dig deeper and search the internet for more details. The application layer, as we spoke before, is responsible to provide an interface between the applications and the network. This layer has the most number of protocols. HTTP, which is a well-known protocol for you because you use it in the web browsing. DNS, TFTP, FTP, and many other protocols work in this layer. The presentation layer is responsible to format the data. ASCII, EBCDIC, JPEG are all the protocols that work in this layer. Encryption is the other duty of this layer. Session layer is responsible for kickoff, maintain, and finish the sessions between different hosts, which is required for data transfer. The transport layer has some important roles, including sequencing, acknowledgement, flow control, and etc. We will talk about these roles in depth in later videos, as they are very critical in networks. TCP and UDP are the most important protocols which work in this layer. The network layer is responsible for defining a logical network addressing scheme and doing routing based on those logical addresses. Routing is a major topic in our course, and we will discuss different related topics in that context in later videos. IP is a well-known protocol for this layer. The data link layer is responsible for handling the media, how and when the data should be on a specific media, like a cable or wireless network or whatever. All of them are determined by this layer's protocols. HDLC and PPP are two examples of the protocols that work in this layer. And finally, physical layer defines all electrical and physical aspects of devices and the transmission media. One more thing and we will go for a quiz. There are two rules for every single layered architecture model. First, same layer interaction. This rule indicates that the same layers of both sides of a conversation will understand each other. This means the header that adds to the network layer of a transponder side, for example, is understood by the network layer of the receiver. So if network layer on side A adds a header to the data, this header is understood by network layer of computer B, and it can interpret that data. Otherwise, the data transfer is impossible. The other rule is called adjacent layer interaction. This rule indicates that each bottom layer is responsible to provide the right services to its upper layer. For example, network layer is responsible to provide services for the transport layer. Okay, it's quiz time. What is the question? Which of the following networking models is called a reference model? First, TCP/IP, then OSI, IPX, SPX, or ISO? And you're right, the answer is OSI, because the OSI is our reference model. Alright guys, this was today's video. If you enjoyed it, please do not forget to like the video, subscribe the channel, and put your comments down below. Thanks for watching.